with you about printing, 3D print in polymer, in thermoplast, instead of printing your parts in metal. And what that means, because we see more and more consideration of using high performance plastics instead of metal. Today, Tim Wadzitlo, our senior application expert, is joining me. And hello, Tim. Tim will be my lifesaver probably at the end of this presentation, where you might have some questions. So we'll try to build in some time to allow you to type a couple of questions. And that's the benefit of being live. And Tim will be able to I'm sure we'll be able to answer them. So let's get started. First, let me say something about INTAMSYS. INTAMSYS is a China-based company. We have by now on our way to become a fully global company, worldwide sales offices and support operations in EMEA. We are based in Stuttgart, in Germany, and also since recently in Minneapolis, for the US, for the Americas region. And we're there to help you and to help our customers to become successful. Successful in what? Well, I will tell you. We have started to develop, based on FDM technology, end-to-end additive manufacturing solutions that are specifically tuned and targeted towards printing high-performance 3D printing polymers. So nearly all of those systems are actually high-temperature capable systems. As such, we are. How could you please mute? Thank you. We have in total nearly 1,500 systems installed, and that's quite a lot. Most of them of our entry industrial model, and lots of them are used for peak. So currently we have a range of printers, high temperature printers, ranging from 100,000 to 100,000 euro, just to give you an indication. We sell our solutions obviously there where these high performance materials are being used, for instance, to have strong parts, light parts. And you see them obviously in aerospace, but also in automotive, in electronics, in medical, and you will explain it a bit more later, as well as in many other high-tech industries. I would say let's get started on our journey. But before that, just to give you an idea what it means that we offer. Yes, we offer a number of systems, a number of printing systems, but those systems are no use without the proper materials. So materials is key. And there is a lot of development in the area of the materials. Therefore, we believe it's really important to have an open material strategy where we lead with a number of materials ourselves. We sell those ourselves, but we have many, many partnerships with various players in the market to make sure that when you start working with the INTAMSYS system, you will get certified and proper results. So that is our way of serving our current and future customers. Now, talking about benefits of 3D printed thermoplast versus metal. I have spent, ladies and gentlemen, a number of years in powder bed fusion, in the land of powder bed fusion, in the land of metal. So I believe I'm entitled a little bit to an opinion here. And I will tell you, since earlier this year when I joined INTAMSYS, I've learned a lot. I learned a lot that powder bed fusion metal printing is definitely not always the holy grail, and that thermoplasts are simply sometimes a better and also economically more favorable alternative. So what do we see today if we look at the market, we see that that thermoplastic products can perform as well as some, and sometimes even better than metal. So this is one. We also see that more and more companies are using or start to use 3D printing polymers, and that means that there's more and more experience here in replacing or in designing metal-like objects, and take the benefits in, specifically when we compare to powder bed fusion or EBM, you know, these kind of parts are commonly used to print real functional metal parts with high densities, 99.7, 99.8%, getting as close as possible, maybe in comparison to conventional manufacturing methods like milling. So one of the thermoplasts that stands out here is PEEK. And we will refer predominantly to PEEK throughout this presentation. And PEEK is a thermoplast that is a great replacement for metal. And it has great mechanical properties, can be used in creating metal-like prototypes for testing or conceptualization, but also for the production of end parts and replacing steel, titanium, aluminum, and so on and so forth. Those benefits that you might gain, so that are up for you for consideration when you want to maybe replace some of the metal parts that you have in mind and benefit from the polymers, those benefits can be classified as weight reduction, enhanced part performance, very important, production benefits. So then it's not about the part and the attribute of the part, but about the ease of production compared to producing in metal, in 3D metal. The economics, and last but not least, a larger freedom of design. So let's take a deeper dive towards all of those. When we are looking at weight reductions, what we see is that we can achieve weight reductions up to 80%. And this is obviously dramatic in a positive way. And that is because we see a way lower mass per cubic centimeter. The weight of PEEK, for instance, is 1.3 grams per cubic centimeter. And this is less than half of that of aluminum and 1/6 of that of steel. So compared to an additive manufactured part made from steel, the same part made from thermoplastic could be up to 6 times lighter. So this is dramatic. Obviously, there is more to gain. The weight reduction, it's not only, we can also gain weight reduction not because of the lower mass, but because we build those 3D parts with FFF or FDM technology. This allows us more freedom of design and allows us more optimized part design, easier to remove supports, more flexibility in the design. So less restrictions on the design. Therefore, we could, depending on the part, we could also reduce the amount of material and save more weight. And you know, these weight reductions are great. You know, it leads to less friction. It leads to longer lifetime of the part. Less friction means less energy loss or less energy needed, less fuel needed, for instance, if it's a vehicle. Reduced logistic cost if we need to ship parts around, and so on and so forth. Second cluster of benefits related to the part itself is the enhanced performance. Very, very important, because if you need a functional part and you want to replace it from metal into maybe polymer, you have to really respect the functional attribute of your current metal part. So part benefits range from extended lifetime by eliminating corrosion, getting more fuel efficiency because of lower friction, handling higher loads speeds, and operating in more extreme chemical environments. So typically parts benefits are, and this is not trivial, the high level of inertness. It's really thermostable, really stable part. If you use PEEK, for instance, with a very high chemical resistance. So the part, as an example, the next, placed next to the bullets here, the oil pump made of PEEK is typically resistant to corrosive gases and liquids. We've seen samples where also filters, in Navy ships, in marine ships, in Navy ships and vessels are actually, eaten away by the salty water and now printed more lightweight using, carbon fiber filled polymers and lasting way longer than previously the metal part would last in the salty water due to that chemical resistance and that inertness. So very important. Corrosiveness, very important for certain applications. With that, there is also the effect of self-lubrication. Normally, if we take, for instance, a gear, it would be typical to use oil to basically lubricate it, to let it run smooth. And that is absolutely important to understand that these polymers are self-lubricating. I'm not sure under which circumstance we still might need certain lubrifications, oils or other lubricating chemicals. I don't know, but generally speaking, this is a benefit. With that, there is also low friction coefficient and a low abrasiveness, which usually translates in a longer lifetime of a part. Noise reduction, something easily overlooked, but in certain applications, definitely if it's for consumer applications or when there is operators that work next to certain machinery all day, noise reduction can be a very important argument. And last but not least, specifically in aerospace, but also in other industries, flame retardant is another important attribute. Let's take a closer look to the next point that does not directly relate to the part attributes, but if you believe you can meet your specification for the part based on, for instance, PEEK polymer or other polymers, then look at what it does to your production and what it means to your production benefits. First and foremost, your production will be faster, at least faster compared to, on average, powder bed fusion systems. It depends how many lasers you run. I mean, many of the systems have only one laser. If it's 4 or 12 lasers, as you've seen even nowadays, it becomes already somewhat of a different story, but then you're talking about systems that cost millions. And in our case, the largest system is roughly 100,000 euros. So there is a large difference, obviously. We try to compare apple to apple. So faster production, due to faster build times, less job preparation, that's very important. Your changeover times, if you run powder bed fusion, you need to change over to the next job, you need to depowder, you need to clean. Depends if you continue with the same powders or switch even your powders, you have to clean even more. You have to heat up again, which can take 1 or 2 hours, all depending. So easily 2, 3, 4 hours are lost just to change to the next job. So job change is an issue when you print functional parts in metal. And with the FFM systems, you more or less can continue your printing all the time. So machine equipment efficiency is much higher besides the actual building speed. Then, in order to get the final part, what about post-processing? There's no need for heat treatment of the metal part for a few hours to release the stress. There's no need to resurface or grind your build plate after the build. Take the cost for that, go through the process and start building again on a new plate. until the whole plate has worn out and you need to replace it with new build plates. So this is really cumbersome. You don't have any of that. And that really translates in faster production and, fair to say, also lower cost of operation. That faster production does also serve you very well, by the way, if you do product development. Because of the fast iterations, you can move to your next version very quickly, test it off, make iterations, move forward, and this way really pace up your product development and final product delivery. Also there we see benefits of using polymers and a different process of production. Yes, not last but not least, because we're not there yet, but I see here less health and safety, and this is also true. Having worked with powder bed fusion systems, you don't have the risk of inhaling metal parts. There's no operator protection needed. There's less fire hazardousness. I mean, no change of filters with metal powder residue that might explode and catch fire. No nitrogen or other gases used. Less heat generation because we don't use highly powered lasers to melt the powder. And the material itself that we deploy is fire retardant. So truly less health and safety risk for your operation. And last but not least, much easier handling of material and ease of use. Generally speaking, I know from working with the powder bed fusion system, you need to be nearly a PhD to get it right. At least you need to be a pretty skilled operator. And deploying fusion filament machines, working with filaments is something that is absolutely more accessible and has less variables to control. And that makes quite a difference. Just to zoom in on production, because we've talked so far all the time about 3D printing parts, but what about a two-step process? If you want to still produce conventionally, but actually consider maybe to 3D print your tooling, like the molds. And this is interesting because printing molds is something that's more and more considered also not to do so in metal, or when you do in metal, then at least not by machining the mold. And I tell you, it's a big difference. If you get a good mold done in PEEK, for instance, your readiness to get your first shots of injection molded parts out is so much faster, because normally a mold will take quite a few times, quite a few weeks, if not some months, before they can be delivered. 4 to 6 weeks is, I understand, quite common. So you can get your first shots done very quickly. When you're still in iteration phase or you need pre-runs, this is super interesting. And your time to market will, of course, shorten. You can even cut months out of the process. And your initial cost, or your cost of making the mold is 60 to 90% less. So having all said that, of course, if you do long runs, I would say the number of shots you can do and also the cooling you can apply to metal molded parts is different than a part that is made out of PEEK. So there are differences, obviously, but for shorter runs, the economics are great, even though maybe your pace of production or before you're ready to do your next shot might be a little bit longer than in metal. For shorter runs, and this is hundreds or up to the thousands even, depending on which plastics you inject. These shorter runs are definitely to be considered. Better economics, we touched upon that. Another benefit, low depreciation per part. Yeah, I mean, the equipment is by far not as expensive, so you're not gonna depreciate so much. Faster build, if you can produce more per time unit, you get more output. That means, and that at a lower depreciation. So your cost or your depreciation per part is definitely more beneficial. And less job preparation compared to metal, and specifically powder bed fusion or EDM. And that is obviously something to take into account, because that machine efficiency can be so much more higher using the FFF technology compared to powder bed fusion. Last but not least, lower energy consumption will definitely also help to get costs down. The last bullet I addressed in terms of benefits is greater freedom of design. I think we've understood that already on the fly. The FFF technologies does provide certain benefits over metal, greater processing possibilities, lighter weight material that affects the need for support, removable or easy to remove support structures. And you can make certain objects that could not maybe otherwise be made with metal additive manufacturing, reducing, for instance, even more weight. Now, let's just see what that means in a quick overview if we look at the various industries. For instance, in automotive, 3D peak printed parts could improve your fuel economy and reduce your emissions. And if you get less friction, for instance, in your powertrain, you can reduce 70% weight in your gears, and that can lead up to 10% increase in efficiency due to the lower weight and the lower friction. Noise reduction, I mentioned that earlier. Just to understand, a gear made out of metal in action with the noise, with the vibration noise, is lowered by 3 decibels if you print it in PEEK, or if you use a part that is printed out of PEEK. And that is equal to 50% noise level reduction for the human ear. So if you can offer that to workers close to the equipment, that is a serious benefit. Yes, and you know, probably the most used application area, or the most, I would say, common application area is in automotive is fixtures. And there are many fixtures used. Some wear out, some need to be very stiff. Some, because of this, they use them still in metal. But replacing metal parts with high strength plastic fixtures is really, really beneficial to reduce weight, to make it so much more friendly to work with, less weight to carry for the operator. You can make your tooling and your fixtures very, very fast as you print it on the fly, and the next morning you have your tooling or your adjusted tooling design. And this obviously can also all happen whilst saving cost compared to traditional manufacturing of fixtures. So fixtures is easy gain, easy win in your manufacturing operations, easy to identify. So if you are into or think about going into 3D printing and you're not yet in, think about there must be tools and fixtures that are easily benefiting from durable, strong plastics. Well, typically for automotive industry, driving gear, reducing weight, self-lubricating, as I mentioned earlier on, more silent. If it's in prototyping or in motorsport, fast prototyping, fast production, easy process. Fixtures, just mentioned about fixtures, fast lead time, low cost for the parts, for the fixture parts, health and safety benefits, as mentioned, due to the reduced weight, strong and lightweight. In this case, we're showing a PEEK sample. Aerospace, obviously, there are various benefits here with weight reduction. You see here a hinge for helicopters. There is here a shell made out of PEEK for a battery and transformer. The shell is made out of PEEK, flame retardant, fatigue durability, lightweight, nice insulating properties. And medical, we addressed it very early on in the presentation. You know, I'm not here talking as a medical specialist, but what I've seen and what I've learned, and I can also compare to my previous exposure to some of these applications in metal is I wondered always, you know, who wants metal in the skull or in the hip? It's a very strange type of material for your body, and so on. And I've learned that, you know, if you can do it with PEEK, and I'm sure there are parts that are not suited to you know, implant parts that are not suited for PEEK, but if you were able to do it with PEEK, it feels much warmer, and it does not have the metal touch. So there is a comfort, a higher, you could say, level of comfort to the patient. It's relatively at a low price when you customize parts in 3D printing to be body implants, and it has great mechanical, chemical, and electrical properties. It is non-conductive, inert, mechanically strong, strong but still somewhat flexible, not necessarily brittle, very important. So I really understand why the medical industry is doing more and more, I would say, implants and parts using PEEK, at least also moving away from maybe standard milling processes to customized PEEK printing processes. Typical applications: surgical tools, prosthesis, dentistry, manufacturing of medical tools and devices. Just showing here a few more. You are all listed, and you will all be able to, at least the ones that registered, to get your hands on the slides later on, as far as you're registered at INTAMSYS. If you did not register through INTAMSYS, by the way, just drop us a short mail or note, and we're glad to share the PDF of this presentation. Yeah, one on the fly, one more to go here in the medical industry. PEEK, a brace, extra body, this outside of the body, high tensile strengths here, durable, protective, lightweight, very important. You need to walk around with it, and a nice smooth surface finishing. Last but not least, electronics. We see quite a few initiatives in electronics using PEEK. In this case here, by the way, combined here with an elastomer to make short runs, smaller quantities. It's a fast process to develop to production. Obviously, for connectors, if you want to do mass production, there are other ways to print them or to produce them much more cost beneficial than using 3D printing. But for initial conceptualization, custom build, special need, there is also in electronics with the inert and non-conductive attributes of PEEK. There is really a gain. All right, that sums it up in terms of telling you and sharing with you some of our experience and view on why you might consider thermoplasts, high performance materials such as PEEK, and print those in 3D instead of using metal in the conventional way or 3D printed metal. I'll leave that up to you, and we're very happy to learn more from you and see if we can provide some proof of concept if you wanted to put some of your designs to the test. So if we would put that to the test, ladies and gentlemen, we have that portfolio that I just referred to in the beginning of our presentation, a number of models. There's more to come next year. We're really aiming here for leadership in terms of high temperature capable printing systems ranging from 6 to from the lower end here, from let's say 6,000 euros up to the large Pro 610 HT with 300 degrees chamber temperature, 500 degree nozzles, more than 0.5 meter by 0.5 meter by 60 centimeters, with a lot of production feature controls. All of them are open material systems in order to work with those materials that give you the attribute that you need for your parts. That's it on this topic. And I'd like to hand over to our moderator and invite Tim into the scene to understand if we have any questions. I see some chats here. I think some were meant for me, How? That's okay. I'm not sure. So is there audio yet? I don't hear anything. Okay. Okay, these are small comments. All right.
So maybe let us start with the first question from Adi. Sorry, I can't spell the last name. I just noticed that INTAMSYS added PEEK besides PEC besides PEEK to its portfolio. Can you please comment on the PEC versus PEEK FFF in terms of both processability and final properties? So this is definitely something where we could speak a half hour or even an hour about. You definitely see difference in terms of impact strength, tensile strength slightly. But overall, if you start with a group of PEEK or PEC materials, PEC is definitely easier to process than PEEK. So this depends a little bit on your application in the end. But if you would like to start with a material and you have no experience before, I would recommend to start with PEC. If you have more questions regarding this topic, feel free to come later again, closer to us, to have a private discussion about this.
So, Tim, can I ask you to do another 1 or 2 questions, also with respect to time?
Yeah, for sure. Would you like to pick up the questions, Bart?
Oh, I don't see them in front of me. Okay. I'm just looking at my own logo here, everyone.
So we have one short question from Kevin Heidkamp. Is there a dual extruder in one of the printers? Yes. The Pro 410 has a dual extruder, and also the Pro 610 HD has a dual extruder. We have another question from Markus Axelsson. What support material do you use for your PEEK material, and how is the removal of this support? So definitely support material with PEEK is a very, very hard topic. We have a material that we call a hybrid support, so that it can be softened with a chemical substance and then removed with handwork. But this is definitely not the final solution in the market, and we see that some of our materials partners are looking for something better. So this is something where I can't give a straight answer yet, and where you will see improvements in the next months and years. We have a few more questions. Let's see to pick up the last question to respect the time frame of all. Let me take a look, please. So for the overall cost reduction, this is definitely a point where you need to the question is, for the overall cost reduction, you have taken into account more expensive material costs. Is this correct? Right, this is a question that you may can answer better.
Well, obviously, if you start deploying PEEK instead of stainless steel, you are talking $600 or euros per kilogram versus powder that is maybe 60 euros a kilogram for sintering powder. But don't forget that in order, you have a weight difference that defines how much, that has an effect. There are other effects in place. So what has been stated is not necessarily true for every part. That will require obviously a part analysis and part study. Obviously, when you are looking at titanium, for instance, that goes at 300 to 350 euros per kilogram for sintering, it becomes already quite a different comparison. So Tim, I think there are many variables, and this is one that would require some investigation if you compare, for instance, only against stainless steel. But again, stainless steel is 6 times more heavy per square per cubic centimeter. So there are other factors that come into play.
And there's another thing that we should also mention is still the design of freedom. That means not only a design specialized to FFF, that means also that we can print parts hollow or with only 20% of infill, which makes part even more lightweight.
Yes. All right. That's a good one. Shall we take one for the road, one last one, and then we'll wave goodbye to everyone?
I think there are 2 more questions. Let me choose one of these. There's one question: what are the typical build rates for the 410 and the 610 machines using PEEK material?
Good question.
This is definitely a good question, but definitely something that you can't answer that exactly. Yeah. Well, let's say we compare to resin technology, where we have a screen, then we can say, okay, 1 layer takes exactly this time. On PEEK, it's definitely not possible to give a clear answer. Well, it depends on your geometry, and this is a huge difference, let's say, to SLS technologies, where you every time fill up your whole build volume and you print as much parts as you can, where you here maybe go for different parts in different orientations. So
I guess, Tim, the only thing we can say is extrusion speed that ranges from how much we could extrude with a nozzle over time, depending on the type of nozzle and the settings. But roughly an indication of the extrusion speed could be a partial answer to this question, right?
Yeah, but even this is hard to answer here yet. So okay. I would definitely like to take this question back and go into a private conversation.
Then let's make sure we can answer the last one if there is still one left.
The last question is: did you print bionic complex part with a soluble support material? So the question is yes and no. While there is no soluble support material in the market yet, or it seems that they are starting to get some soluble support materials for high performance polymers like PEEK or ULTEM, but definitely we print bionic complex structures out of polyamide or PC where are already soluble support materials available. So this is something where it definitely depends on your base material, let's say, for your build material itself.
Okay, so I think this sums it up. Thank you so much for your high level of attendance throughout this half an hour, and really, we wish really everyone a good conclusion of the day, and I hope to see you in person next time around at Formnext. We all do so on behalf of INTAMSYS. Thank you very much, and
thank you.
Thank you.
Bye bye.